and gents. Let's go ahead and get started here. So the purpose of me giving you notes this time around is I noticed on the last test, not everyone had notes to use, apart from the ones that we did together in class, which isn't a great thing. But also some of the Cornell notes that people were using honestly weren't of the highest quality. This isn't true for everyone, of course, but I want to take the opportunity, since today we do have to talk about notes and get you guys some notes right off the bat, is to maybe show you guys what I think really well written, well formatted Cornell notes look like, and to make them really useful to you. So of course, being this is a video, you can kind of pace yourself. If you need to pause, rewind, do whatever you have to do. But also, if you have questions, call me over. I'll be happy to explain things in a different way than I'm explaining them here. This shouldn't take more than, say, about 20 minutes, but hey, let's get into it. I also want to talk a little bit about why each part of Cornell Notes is really important, and maybe give you guys a sense of how to do the summary and essential question connection a little bit better than what I saw in general. So a really important part of Cornell Notes that a lot of people skip, I don't want you to skip this, is this top part, the topic objective and the name and stuff. This is really an organizational thing, so as you're flipping through your binder, flipping through your notes, and you're looking for a specific topic, if you do this part well, then you should be able to use that as a reference. And so we are going to talk about polygons today. We'll talk about what polygons are here in a second. But also don't forget your name, your block, and the date, I guess, is a little bit less important except for organization. But the name and the block is actually important because if you leave them in a different class in the hallways, I have had notes returned to me that I was able to give back to the students so they don't have to take it a second time. So anyway, the next really important part of Cornell Notes are the essential question. Good Cornell Notes are very targeted and they're very specific. One thing I saw people doing is kind of cramming all the information onto paper, on like to a single Cornell note paper. This isn't good. I mean, I know like it's efficient that way, so you don't have a ton of notes, but it's also unusable because the notes are so compact. It's really difficult to find the information you actually need, and so. The essential question should come easy. Sometimes you do the essential question last, but since I'm setting those up for you ahead of time, the only thing we're going to talk about today in these notes is how do you identify common quadrilaterals. And so in the end, like this basically is identifying a huge test topic, and this is something we'll test you over later. How do you define common quadrilaterals in geometry? Now we'll go about defining those terms here in a second. Now, as we start in the notes itself, it's important that on the side these are framed as questions, not statements. The reason you want to frame them as questions, although that is more difficult, if you force yourself to think in terms of questions, you not only give yourself something to look up or to find or to study, but you're also predicting what type of test questions I'll ask. And certainly on the next test, you're going to have to know a bunch of terms. Like they were on the last homework, it'll be on the next set of homeworks too. And so these are the common terms you have to know just to engage in this topic. And so let's go through them one by one, but we'll go through them at a pretty fast clip. So the first term is polygon. So polygons are any shape that's enclosed, two-dimensional, and has only straight sides. So there are actually three conditions for what we call a polygon. And so like, the best way I can explain this is to show you a list of polygons and a list of non-polygons. And so polygons are enclosed, two-dimensional, which means they're flat, and only has straight sides. And so a polygon is going to be really something like this, or like that, or if I can freehand draw, that's not bad, like a hexagon. Look, those are what we call polygon shapes, and certainly something like a triangle would also be a polygon. If you want to talk about non-polygons, what we're basically saying is that it doesn't have one of these qualities. It doesn't have to violate all three parts of the rule, but at least one. And so something like this, that would not be a polygon because it is not enclosed. It has an opening right here, meaning that it's not a polygon. If we want to evaluate the 2D thing, we can create something like a cube. A cube is enclosed. A cube has only straight sides, but a cube is not two-dimensional. Because it's not two-dimensional, it's not a polygon. If we want to evaluate the straight side part, all we have to do is make one side curved. And so something like this would not be a polygon because of that curvature line. Also, just as a note, this is not a polygon either, because even though it is enclosed, it does have straight sides. This is technically two polygons, and because these are two polygons, it's not a polygon. Okay? And so that's what we mean by polygon, and that's really kind of like the big basis for all our discussion. That's why we're calling this polygons. So we have to know the difference between the two. So it's either straight-sided, enclosed in 2D, or it's violating at least one of those rules, and we call it a non-polygon. Vertices or vertex, those refer to the sides or the corners, excuse me, on a shape where sides meet. And so like for a triangle, there's a vertice, there's a vertice, and there's a vertice. Okay, so this triangle has three sides, which means three sides have to come together to meet. Hence, it'll be three vertices, and that's really all there is to a vertice. It just refers to the corners. Consecutive. This is similar to adjacent. Adjacent just means touching. Okay, and so the term consecutive just refers to within a shape, within a polygon, two things that are touching or adjacent to one another. And so let me kind of draw this one. So adjacent sides would be like this side and this side. These are adjacent or consecutive. Because they're right one after the other. So those are consecutive, in this case, sides. There's also another case of consecutive, and that could be for angles. Again, let me kind of draw this guy. And so I would also call these angles consecutive. And that's because they're in a row. Okay, so if you have two angles in a row or two sides in a row, we call those things consecutive. The term opposite, again, looking at the definition, opposite refers to any sides or angles that are cross. In other words, not adjacent, that should be not adjacent. And it's a counterexample to consecutive. So again, let's draw a picture first. So if I have like a picture of what could be a square, opposite side refers to these guys. Those are opposites. Okay? And it's because they're across. Okay? Another example, and I'll put that in pink, could be these two angles. These are going to be opposite because they're across. Okay, so we have two versions of opposite. We have opposites in terms of sides because they're across from other, not touching, not adjacent. We also have opposite angles for the same reason because they're not in a row and they skip an angle, they're still across from each other. And so these two ideas are in opposition to one another. We have things that are consecutive, meaning they're touching in a row. We have things that are opposite, which means they're across from each other or they skip an angle in between. The last definition I want to talk about, or want to talk about with you, is going to be diagonals. Now, diagonals just refer to segments that are not side lengths, so they're not referring to the things that actually make the shape, but they do connect vertices by going across the shape. And so what I mean is this. If you consider this vertex and this vertex, that's a diagonal. Okay, a diagonal goes across the middle of the shape. It connects two vertices, but it's not the side length itself. So there's another set of vertices. Okay, there's the diagonal. Because again, it goes across the shape, connecting two vertices, but it's not the side length itself. It has to go across. Another way to say that is that it can connect. It's another thing that it does is connect opposite angles. And so that's another way to think about it. And so this is a very common thing to talk about first, especially in geometry where we have so much language we have to deal with. Always talking about the important vocabulary terms. And you can kind of guess again, like those are going to be on the test. And so those are terms we have to be really familiar with. And we'll use them in context as we go. So getting the definition down is just the first part. Okay, so next big question. What is the difference between a definition and a characteristic? This is something that we'll be playing with today in the near future. And so my claim is this. When you look at a shape, or really look at anything, there's two things you should know about it. One, what defines it, and two, what are the characteristics of that shape. Before I give you the definition and characteristics, let me give you an example first. So take, for example, Pepsi. Okay? There's something that defines Pepsi and there's something that characterizes Pepsi, and those two things are not the same thing. And so if I want like the definition of Pepsi, what I'm talking about is basically the recipe of ingredients. Okay? In other words, like what actually makes Pepsi, like how much sugar, how much this, how much that, how do you mix it, how do you cook it for how long? That's what actually defines Pepsi. It defines Pepsi because it's actually what you need to create Pepsi. And ultimately, that's what I mean by definition. It's a minimum set of rules or requirements needed to create a shape. In this context of Pepsi, it's what's needed to actually create Pepsi. Um, in contrast to that, if you think about the characteristics of Pepsi, okay? The characteristics of Pepsi, well, I'm talking about like how is Pepsi? How does it taste? Is it smooth? Is it sugary? Is it sweet? What are the things that's true about Pepsi once you know you have Pepsi? And so, um, if you talk about characteristics, characteristics don't have to be unique to Pepsi. Okay? Like it's not true that Pepsi is the only sweet beverage. It's not true that Pepsi is the only cola beverage. These things are true of a lot of things, but they're also true of Pepsi, and that's really what a characteristic about. And so all the things that are true about a shape once you know you have it. And so you look at the difference between definition and characteristic. A definition speaks to what you actually need to create a shape. A characteristic talks about what is true about the shape once you have it. And you should also make a note here, and that these are not unique. Okay, so so what's true here about a characteristic, you can definitely say is shared amongst other shapes. Okay, in the same way, there's lots of things about Pepsi that are true of other soft drinks or the sodas. Um, those are characteristics. Over here, though, this is completely unique. Okay, there's only one recipe that gets you Pepsi, and no matter how much people try to imitate it, what they're making isn't Pepsi. Like a generic cola, like store brand cola, will never be Pepsi or never be Coca Cola as much as it wants to be. It'll always be a different recipe, so it'll always be a different thing. But even if it is a different thing, like that off-brand soda, that store brand soda, it's still sweet, it's still sugary, it still has some things that Pepsi has, and so they do share characteristics. Now, the reason that's important is because now we need to talk about the shapes themselves. So when we talk about these shapes, these common quadrilaterals, uh, how do you tell them apart from one another? In other words, what's the definition? And so I have the definition outlined for each one. So I want to share the definition, talk a little bit about it, and maybe offer you like a picture that you can key in your head what the shape looks like. And so let's start with this. So you've noticed these are all set up um, as if-then statements because these are conditional. If you meet the first condition, if you meet the fact that a shape is a polygon with just four sides, then you can conclude that the shape has to be a certain thing. In this case, if it's a polygon, so it's enclosed, two-sided with only straight sides, and it only has four sides, and that's the only unique restriction, well, we can say it's just a quadrilateral. A quadrilateral is defined to be exactly what you have here. It's just a polygon with four sides. There's no special relationship amongst the sides. Nothing has to be parallel, perpendicular, or whatever. It just has to have four sides. And so there's lots of examples of what a quadrilateral may look like, but it's just nothing special. It's like that's a quadrilateral. Uh, this is a quadrilateral, but also something very specific can be a quadrilateral. So even something like this that I'm trying to and failing to draw a square here, that would be a quadrilateral as well. And so as long as it has four sides and a polygon, then it's going to be a quadrilateral. If we start to add specificity, we start to be able to target more shapes. And so if a shape is a quadrilateral with two sets of parallel sides, then this is, and again, the key set here is two parallel sides, then it is, in this case, a parallelogram. Okay, so if we try to draw that, we need to have two sets of parallel sides. So if I draw a top, it's got to be parallel to the bottom. If I draw a side, it's got to be parallel to a side. Now, in terms of marking this, let's remember that if we have parallelisms, we have to mark it. And so that's what I'm looking for a parallelogram. Two sets of parallel sides. Moving on to the next one. If a shape has two sets of congruent consecutive sides, then it is like height. Okay, let's talk about how this would look. So two sets, I know the comma's weird there, it threw me off too, I must have mistyped that. So two sets of congruent, okay, so remember congruent like this, consecutive, which means in a row, sides. And so here's how this would look. So I have two sets of sides that are adjacent touching, that are also congruent. And then I have another set of sides to do the same thing. that are touching and congruent in a row, and we get a kite. There's another picture of a kite as well that does the same thing, but kind of does it in a different way. And so I have two sides here that I know are touching, consecutive, excuse me. And then I have another set of two sides that do the same thing, but I'm going to draw these to the inside. And if you recall, this is something called concavity or being concave. So we have two sets of congruent consecutive sides, and that's what actually makes a kite. That's what distinguishes a kite from other shapes. Okay, and so we have four sides with no restrictions, quadrilateral. Four sides that have to be all parallel to its opposite side. We call that a parallelogram. And then quadrilateral, four sides, in which you have two sets of sides that are touching and congruent. You got a kite. So next one, moving on. Boom. If a shape is a polygon with at least one set of parallel sides, then it, in this case, is what we call a trapezoid. Okay? So at least one set of parallel sides. Remember, parallel looks like this. And so if I have a top and, say, a bottom that are parallel, the other ones don't have to be. We call that a trapezoid. So there's a common look of a trapezoid. We also have variations, so something like this would still be a trapezoid. Because again, we have one pair as parallel, or even something like this. Okay, so this would be still parallel, or I'm sorry, trapezoid, excuse me, because we have one set of parallel sides. Okay, oh, it looks like I missed a word here. So if a shape is a polygon with four congruent sides, okay, we can call this guy a rhombus. Now, a common name for a rhombus is what we call a diamond, but there is actually no diamonds in geometry. They're just rhombuses. So here's kind of the deal. We need four congruent sides. Remember, congruent means this symbol. So four sides are the same exact length. And so it's almost like a square that has kind of been pushed over to its side. And although that's not a perfect drawing, we compensate by putting the correct marks in. That would be a rhombus. Okay, so again, we have two sides that are the same, and the other two sides are the same length. Mark them all the same because we want it to be. That's what we call a rhombus. Okay. In contrast, if we do it kind of a different way, we keep four things the same, but in this case, remember they're right angles. Right angles are 90 degrees, also called perpendicular. So we use that symbol. Then this shape actually is a rectangle. And so a rectangle, the way this definition holds it, is that we have four sides, because it's a quadrilateral. Then we have four angles that are all 90 degrees, because that's the definition. These are right angles. Right angles are 90-degree angles. And then we have a rectangle. Now this also opens a door, and this is something we'll discuss a little later. If you think about a shape, let's say maybe like a square, where all the sides are the same, it still has four 90-degree angles, so we can still classify that as a rectangle. This is in part where that saying all squares are rectangles and all rectangles are squares comes in, because it is true that all squares have 90-degree angles, but not all shapes with 90-degree angles are squares, because we have the case of the rectangle here on the right, where you have four 90-degree angles, but the sides are not congruent, therefore it's not a square, which actually leads us to our very last definition, where if a shape is a polygon with four congruent sides, so all the sides are the same, and then four right angles, which means all the angles are perpendicular, this guy is called a square. Okay. So a square has to follow two rules. One, all the angles have to be right, and two, all the sides have to be the same length. Now, this is no surprise, of course. We dealt with squares pretty much your whole mathematical life, but these are the definitions. And really, that's the case with all of them. Like, I think we could identify these shapes even without these rules, but these rules give us, and again, this is what a good definition does, gives us the bare minimum you need to actually create these shapes. A good test would be this, and you kind of saw me demonstrate this about 7 times. If I asked you to draw a polygon with at least one set of parallel sides, you'd have to draw what's in front of you. You'd have to draw a trapezoid. If I said, hey, draw a shape with four right angles, you would have to draw this, or this as an alternative. There's nothing else you can draw because I've limited what you could. And again, that's what definitions really do. They limit what you're allowed to do. That's why they're often called rules instead of definitions, because they're limiting. And so if you do have a shape that has four right angles and a polygon, you have to draw something you have to draw something that is gonna be this rectangle. Okay. Now, there's something implied here too. Every time you see the word polygon here, you can also add the word quadrilateral. Okay? So we're talking about something that's a polygon that's also quadrilateral with one set of parallel sides. We can do the same thing here. Let's change this to word quadrilateral. Okay? Quadrilateral, quadrilateral. Okay? And that would limit it to 4 sides. And so that's, again, what good definitions do. So if we're talking about a quadrilateral, it limits it to 4 side lengths. Then if we add a further restriction, like, hey, you have to have 4 congruent side lengths, that forces it to be a rhombus. And again, that's all good definitions actually do. Okay, we're going to pause the notes here. And so let me skip down here because we're about to hear an announcement too. Let's talk a little bit about a summary when Mr. McCarthy's finished.
Seniors, please report to one of the 2 following locations. The Performing Arts Center for a session titled How to Pay for College, hosted by MU Financial Aid Advisor Kayla Klein. Or J19 to meet with the National Guard, Sergeant Nathan Herndon. Again, the Performing Arts Center for Financial Aid Assistance, or J219 for the National Guard. Thank you.
And so the last thing I want to talk about in these notes, and I know I skipped over a section, we'll go do that a different day, is talking about a summary. And this is a summary. The summary is, again, a thing I saw in people's notes that they didn't do really great, and I want you to improve upon. A good summary is actually done in 3 parts, and you can read this as I'm saying it out loud, certainly. But a good summary first has to start with you rereading your notes, just reskimming your notes. And today's notes weren't honestly very deep, which is why I'm taking the opportunity to do these by video. But you have to do that. You have to go back, reread your notes, and kind of have that argument again in your head. The whole time you should be thinking, did you answer the essential question? And for today, the essential question was, how do you define common quadrilaterals in geometry? And so we had some definitions here. We talked about the difference between definition and characteristic, and then we actually defined the things. And again, we noted here that there's a lot more true about these shapes than what I'm telling you in a definition, but the definition is forcing you to make these shapes. And it's certainly for something like a quadrilateral, like a rhombus, there's more to it than just having 4 sides that are congruent. But that's the definition or difference between definition and characteristic. A definition is minimal. It's just exactly what you need. Okay. As you're reading, you should highlight or underline 3 words or phrases that are important to answering the essential question. You don't have to use a highlighter, but I'm cool with highlighters. And so you should be thinking, how do I answer this question? What words or phrases within the notes should I use? And then the final step is writing a few sentences, just maybe 2, 3, 4 sentences, using those highlighted words or phrases as best you can in answering the question. You should think of a summary almost like a movie trailer. And so it doesn't retell you all the notes. What it does is basically answer the essential question and give you the highlights of the notes that you should think about. A summary should never be like, all the stuff above is really important. Well, of course, all the stuff above is really important. You're trying to target the stuff you absolutely need to know to answer essential question. Okay, so finish up your notes here. Once you're finished, I have some work for you. So once you're finished, flag me down, and I will get you the notes or get you the next part, so you can get started right away. Okay, we have a couple more questions here we're going to answer, but we're going to answer those later. And so you can start new notes for those, or you can leave some space in these notes if that's going to be your thing. Okay, but don't worry about these 2 questions for right now. We'll answer those at a later time. Okay, so that's all I have for you guys right now. Thank you. And after you're done with the notes, flag me down. I'll get you the work. All right, thanks.